before we take a look at our classes, I would like us to have a quick look at exception handling in that we were supposed to talk about that one on our last meeting, but because of time, Kenneth couldn't talk about that. So we'll have a quick look at exception handling in that, how to use a try and catch, try on, and then finally block, and look at stack traces and how to create custom exceptions. It will be a very quick one. We wouldn't spend much time on it. So exception handling. Exceptions are mostly some errors that occur when we are running our program. You see, sometimes when you write programs, errors occur and the program crashes. Yes, so when you handle these exceptions, the program or the application that you are building wouldn't crash. So there are a lot different types of built-in exceptions in that programming language, but the most common ones that you normally come across are range error, type error, unsupported error. But with the unsupported error, it's being grouped into different types. You have integer division, and the other ones are normally associated with the OS that you are using. Sometimes you are using it. For instance, let's say you are dealing with notification systems. You see, notification works differently on Mac OS. It works differently on Windows, Android, and iOS. So if you are working with notifications or something that's OS specific, that's where you get the unsupported error. But the integer division by zero exception is also categorized under the unsupported error. We'll look at that in the text editor very soon. So let's look at how to use the try on keywords, and let's look at the try on keywords and how to use them in that. It says in that the try keyword is used to enclose a block of code that might throw an exception. So if you write any program that you know might bring out an error or bring out a certain exception, you enclose that code in a try block. The on exception is used in combination with the try when you try to specify the type of exception that might be caught. So we will look at that in the text editor. Okay, it's here. So let's say you have a certain code that might show an exception. That code comes here. Then you have the on block, then the on keyword, followed by the type of exception that this code might provide. In case this code might throw more than one exception, you have exception type 1, then exception type 2. In the example above, the code inside the try block is executed. If the exception is shown, the on clauses are checked in order to see if any of them match the type of exception. If a matching on clause is found, the code inside the block is executed. So like I said, the code that might show an exception comes here. Then if there is an error, then the on block will match the type of error that occurred. If that type is here, then it will match with whatever is being written here or whatever it's supposed to do here. Try and catch. The try and catch are used to handle exceptions or runtime errors. The catch clause is used when you do not know the type of exception to be thrown. Over here, when we look at the on exception, I said if you know the type of exception that will be thrown, maybe you know with the code here the code that you have here, you are sure that it is going to throw let's say an integer division by zero error. So you come here and you say on integer division by zero error, do this. But let's say you don't know the type of error that the code might throw. That's when you use the catch keyword to catch any other exception that might be thrown. So we will take a look at that in the text editor. I don't know if anyone else is on Linux. I'm having a problem sharing my entire screen, so I would have to stop presenting here, then present again in the text editor. I don't know why that's occurring, but I've tried on different computers, it didn't work. So we'll take a let's look at these slides and then we'll go into the text editor and see how to do it. Okay, so here when I try the catch here, the catch keyword is here. Then the catch works more like a function. So you pass in a parameter. The parameter you pass in will hold is it holds the object of the exception that will be shown. So over here you will say when an exception is being caught, this e will hold that exception that is being caught. Then whatever we want to do with that exception, maybe we want to print that exception, we can just say print e. Then it will display that exception that is being shown. And okay, so the explanation comes here. In the example above, the code inside the try block is executed. If an on if an unknown exception type that was not handled on the on clause. So over here we specified exception type 1, exception type 2. So let's say if exception type 1 was not shown, exception type 2 was not shown, but there was some other exception that was shown which we didn't know of. This catch keyword will catch that exception. Then whatever is being written here will be executed. So that is an exception type that was not handled by the on clause. Exception is true. The code in the catch block is executed. So the stack trace. Let's look at how all of these are being done in the test editor. Then we look at stack trace before we come to stack trace. Okay, so earlier I talked about some of the examples of the most common exceptions that we normally come across when we are programming or writing code in that. Some of these um, exceptions are range error, type error, and integer division by zero error. The range error normally occurs when you are dealing with lists. When we are dealing with list objects, then you go outside the number of items inside the list. So let's say you have a list that contains 5 items, then you try to access a number which is outside, which is more than the number of items in that list, you get a range error. So for instance, let's say we have this list here. A range error example is the name of the variable. It's a bad name, but forgive me. So this variable has 3 items, and we all know in lists that when you are counting the indexes, we start from 0. So we have index 0, index 1, index 2. So if you try to get something at index 3 or index 4 or any other index that we don't have, we might get an error code, we might get a range error exception. So over here, we are trying to access the item at index 4, but we all know this, we don't have any item at index 4. So when we try to print example, okay, you see we have an unhandled exception, range error. Yes, because we don't have any item at index 4. We are trying to access something that we don't have. But when we try to access something index 2, we get 2, and we get 6 index 0. When we try to access more than what we have, that's where we get the range error. Okay, so let's move on to Let's look at integer by division um, error before we come to the type error. So the integer by division, as the name goes, integer division by zero. We all know in math that you can't divide a number by zero. So whenever you try to, let me comment this out. So anytime you try to divide any number by zero, you get an error. You all know that in math. And in that programming language, or in almost not almost, it's not accepted in any other language. You can't divide a number by zero. So when you try dividing a number by zero, you get okay. So let's say we try to run this program. We handle the exception. We have integer division by zero exception. You can't divide a number by zero. That's an example of the integer division error. So let's look at the type error. With a type error, let's say, let me comment this one out. The type error mostly comes when you are trying to perform an operation. You are trying to perform an operation on a type that doesn't support that operation that you are trying to perform. For instance, you are trying to add two numbers. We all know we can only add numbers. You can't add strings unless maybe you are doing string concatenation. But you can't add a string and a number. So those are two different types. So when you try to add, and let's say you try to print out this wouldn't allow me to run because it has already detected that there is an error, a problem here. It says the argument type string can be assigned to the parameter. So you see, you can't add a string, and an integer. So this, when you run this, you get an error or an exception. You see, you can't. This is an example of the type error. Division by zero exception. So let's say we have an integer, let's say numerator, and let's not forget that we have to always bring a try block before we can bring a catch or an on block. You can't catch a block without you can't catch an exception without the try block. The try block always has to be there. So we first have to bring the try block. Let's do that first. So let's try, and let's say you try to perform a mathematical operation. Let's say so. Now we all know that when we try to print this out, we are going to get um, integer division by zero exception. So we need to handle this exception so that when we run it, the application wouldn't crash. So that's when we introduce the on clause. So you try the logic goes like this: try int results equals 12 divided by 0, integer division by 0. And on an exception, on integer division, so as I was talking about, integer division by 0 exception. So on this error, on this exception, integer division by 0 exception, then we do something. Maybe we say print not divide by 0. Over here, integer division by 0 exception is, it says here that it's deprecated. We can't use integer division by 0 exception. That's why inside in the slide I showed you earlier, I placed this one inside the parenthesis, and I told you guys that the integer division by 0 exception is under a bigger class called unsupported error. So over here we use unsupported error. So on unsupported error we print this. So let's run this and see how it goes. So you see we have cannot divide by 0. That's this code is being run. But let's try and divide by any other numbers and let me click on it and see. Sorry, I didn't put this. Okay, so now you see this time around there were no exceptions to it. So the code here is the code inside the try block was executed perfectly without having to execute whatever is here. So unless there is an exception from whatever is being typed here or whatever logic is here, whatever run, unless there is an exception. So let's look at this is how the on block is being used and the on keyword is being used. Let's look at case 2. Case 2 is situations where we do not know the type of exception that is going to be thrown. Let's say you have you want to try something, but you don't know whether what you are doing is going to produce or throw any exception. So let's say we didn't know that dividing a number by 0 will cause integer division by 0. Or let's say we know, but we don't know the name of the exception. Mostly there are exceptions that you might not know their names. For instance, like this unsupported error. You see, when we type, we all know that the exception is called integer division by 0 error. When we type it didn't come. So sometimes you don't know the name of the exception that you are going to get, but you know you are going to get an exception. So in such cases, we use the catch keyword. Inside the catch keyword, we have to provide an identifier. The identifier can be any other strange or any other letter apart from E. But by convention, we mostly use E, as in just as we use I and J in loops. Most of the times you would want to use E here. So let's say we want to print the name of the exception that is being thrown. When we print E here, let me comment the first one out. So over here, we are trying to divide 12 by 0, but we don't know if this might throw an error. So let's say after trying this line of code, we don't know the name of the exception that we will get, or we don't know if there might be any exception thrown. We will use the catch the catch keyword here, followed by an identifier. Like I said, this one we can use any other letter. I'll show you with a different letter very soon. But let's run this first and see what we get. You see, it prints the name of the exception being shown, integer division by 0. Let's try again with a different letter and see if it works. So let's say we try with identifier W. And we come here and print W. It's going to produce the same thing, integer division error. By convention, most people use E. There is no reason. I don't know if there's a reason behind the E. Maybe E stands for exception or something. I don't know. But almost everybody uses E when they are catching exceptions. That's the convention. So this is case 2 when we know the type of exception to throw. Then we will move on to case 3. What was case 2? Okay, stack trace. What is a stack trace? Well, stack trace is used to identify where an error was caused or which part of the code is causing an error. It is commonly used in development to help identify the cause of errors or issues. In the context of exception handling, a stack trace shows the sequence of called functions that led up to the error, with the most recent cause at the very top. So with how do you get the stack trace of an error? So if you want to get the stack trace of an error, you see this catch keyword here. It takes 2 parameters. The first parameter is the E, which is the object of the exception which is going to be thrown. So let's say after we've thrown this exception, we want to know the stack trace, the line of code which is actually causing this problem. So that's where the stack trace comes in. So we'll pass the second parameter to this one, and the second parameter is S. Or it's just like the E, you can use any other letter other than S. So if you try to print the S, this is going to display the stack trace with which error, where the error is being located and everything. Let's try that one out and see. You see, this is the first print statement, printing the exception being thrown, which is integer division by 0 exception. Then we come here to print the stack trace. Wait, you see, it gives you, when you click, you see when I clicked on it, it takes me to where the error is. Over here, you can't divide an integer, a number by 0. So when you click it, it takes you to this part. It takes you to the file and directs you to that line, that specific line of code that is causing the error. So that's what a stack trace is. So we move on to the finally block. I didn't show the finally block in the slide, but like I said, I can't share my entire screen. Maybe it's because of the OS I'm using. I don't know if that's the main reason or there's any other reason. If you know how I can fix it, you can let me know. So if I want to go back to the slide, I would have to stop presenting this one, go back and present again. So let's move straight to the finally block. And the finally block, the finally clause or the finally block gets executed always. Is everything that you put inside the finally block. Get rid of these ones. Whatever code that is being placed inside the finally block will be executed no matter what happens, whether there is an exception thrown or not. So let's say over here we want to do something unique. Maybe we want to print after the division over here, after dividing 12 by 0. You want to say, okay, you want to tell the user maybe move on to the next page or do something. You can put that code inside the finally block, and whether there is an exception thrown or not, that line of code or that block of code is always going to be executed. So let's say when we run this, you see it first prints the exception being shown. After it has printed the exception, it moves on to print the stack trace. Then it prints the finally block. Whether there is an exception or not, the finally block is always going to be executed. So let's try with another number. Let's see if the finally block will be executed. Okay, you see. So over here, I didn't print the results. So over here, you see, we've printed the results because there were no exceptions and there were no errors. This block of code wasn't executed. Then it jumped from the catch to the finally block, and it printed this. So that's how the finally block is. So that's it for exception handling. We'll look at how to create. Custom exceptions. Sometimes when you are building applications and there are exceptions that might be thrown and that compiler doesn't know anything about it. Maybe you've done something with your code, something very unique and specific, and you know that this thing that you've done inside your code is going to throw this type of exception. You can create your own type of exceptions to be thrown inside in that you can create your own exceptions. But before we look at how to create custom exceptions or unique exceptions, you will first have to look at classes, because you're going to use classes to build or to create your own type of exceptions. So before we look at that, we'd have to look at exceptions, and we would have to look at classes. We'd have to look at classes. Okay, so let's go back to the slide and talk about classes. Okay, so we've talked about stack trace when we were in the editor. So we talked about stack trace. All he says, a stack trace is a report of the active stack frames of a certain point in time. At a certain point in time during execution of a program, it's mostly used to help identify errors in a program. Like I said, so here is a syntax for using how to get a stack trace with the S, the second parameter to the catch keyword. Then we move on to the final clause. We've already talked about it. So it is whatever is in this block will be executed no matter what. No matter whether there was an exception or not, it is always executed. Note, the finally clause is always the last clause in the try block. It cannot come before the catch or the on clause. But the catch and the on clause can be interchanged, but you can't bring the finally clause ahead of the on clause or the catch clause. Like the name suggests, finally. So it's like the final thing to do inside